Today we're going to be talking about exponents, and my 8th graders have already seen a little bit of the exponents with the scientific notation, but let's look a little more in depth today. So first I wrote down 5 and a 3, a little 3 above it, and let's label these parts because that's a little bit easier when you're talking about things. So this number down here is called the base, and the number up here is called the exponent. And when you're actually applying this, you're going to be calling this raising it to a power. Raising to a power. So for that one, I would say it is 5 raised to the 3rd power. This one, your base is a, and your exponent is 3. And I would say a raised to the 3rd power. So let's look at 5 to the 3rd. So I'm going to write it down here, 5 to the 3rd. And I'm going to do something called expanded notation. So I'm going to write it out. I'm going to pull it out, 5 times 5 times 5, because exponents just mean that you're multiplying this number by itself that many times. So I have 5 times 5 times 5, which gives me 3. And then I know that that's going to be 125. So this area right here is called expanded notation. It's a little more writing, but if you're having trouble using the rules and laws that we're going to find out, then writing it out might help you. And that's okay. Okay, so let's look at another one. And I'm going to look at that a to the 3rd and see how am I going to write that out. So I write my a to the 3rd. And we don't really know what a is, so we can only write it in expanded notation. If we knew what a was, we could plug it in and find out what that is. And let's look at some different situations. So let's say that I have 2y to the 3rd squared. When I have an exponent outside parentheses, that means I'm applying the exponent to everything on the inside. So not only am I applying it to the y to the 3rd, I'm also applying it to the 2. So this really looks like 2 squared times y to the 3rd squared. And if I wrote that out in expanded notation, it would be 2 times 2 times y to the 3rd times y to the 3rd. I could even go further with that expanded notation by doing this. 2 times 2, and then expanding my y to the 3rd as y times y times y, and this other y to the 3rd, y times y times y. And so now all I'm going to do is I'm going to multiply my numbers, so I get a 4, and then I'm going to count up how many y's I have. So I have 1, 2, 3, 4, 5, 6. So I have y to the 6th. Now going back to that original problem, if I use a 2 and a 3, how could I get to a 6? Well, that's easy. You're just multiplying 3 times 2. When it's outside of a parentheses, you just multiply your exponents. But we'll get it more into those rules as we move on. Before we move on, I have some examples on here, but I want you to look over here in the corner because I want to add one. So we were doing things with parentheses. If you have something like this, though, like 4y to the 3rd, and there's no parentheses around the 4 and the y, then you're only applying that 3rd power to the y, not to the 4. So always remember that. Parentheses mean apply everything on the inside. If there's no parentheses, you only apply it to the number or variable it's attached to. Okay, so let's talk about adding and subtracting with exponents. So I have these two values here. I have 4a to the 2nd plus 3a to the 3rd. I can't add these right now. So I'm going to put can't add. And the reason why is they're not like terms. So in order to have like terms, you need to have this same variable and the same exponent. So going back to this case up here, if you look, they are the same variable, but it's not the same exponent. So let's look at this one down here. We have the same variable, a, and we have the same exponent, 2. So all this is saying is I have 4a squareds and I have 3a squareds. So that means I have 7a squareds. You don't add together these or do anything with them. You're just saying how many a squareds do you have. So you add your coefficients, the numbers in front, so you get 7a squared. Let's look at the next one. I have 10a to the 5th minus 12a to the 5th. Let's check if they're like terms. A's and a's, good. I have 5th power, perfect. So now I take my coefficients. I have 10 and a negative 12. So I do 10 minus 12. That gives me a negative 2. And then I just put my a to the 5th. So for subtraction and addition, you don't change the exponent. Let's look at this one down here. So I want to identify which ones are like terms. I have a 4y to the second. I'm going to look and see if there's any more y to the seconds. Oh, there's one right here. So I have 4y to the second, and I have a minus y to the second. And really there's a 1 in front of there. So it's really 4 minus 1. So I'm going to get a 3y to the second. Now I'm going to look at my next term. I have a 3x to the third. Do I have any other x to the third? Right over here. So I have 3x to the third plus 7x to the third. That's going to give me 10x to the third. And then the last thing I have left is this negative 2y, so I just put it on the end. This is as far as you can go. It's simplified because you can't combine anything because they're not like terms anymore. So that's how you add and subtract exponents. Let's look at multiplying with exponents because we did a little bit of that on the first page. So for my first example, I have 3y squared in parentheses and 2y cubed in parentheses, which means they're being multiplied. So the first thing I do is I multiply my numbers. I get 6. Then I know that I have 2y's and 3y's, so that means I have 5y's altogether. So when you're multiplying, all you're doing is adding your exponents. So you could also write it like this. 3 times 2 times y, and you'd have 2 plus 3 to get that number here, the power. Let's look at another one. I have 7x squared times negative 3x to the third y squared. With multiplication, remember, you don't need like terms, so we don't need to worry about that. Let's multiply our coefficients first. So I have negative 21. Now I have an x squared and an x to the third. That would give me, because I have 2x's and 3x's, that's going to give me 5x's. And then I don't have any more y's over here, but I do have a y squared here, so I just put it on the end, y squared. And that's simplified as far as you can go for now, unless you knew what x and y were. Okay, here's a trickier one. We have exponents on the outside first. First thing you want to do, remember, for PEMDAS is your exponents. So you're going to apply your exponents to this and to this. And you'll apply your exponent to that and to that. So let's rewrite it. So we have 3 squared, which is 9. We have y to the third, but we have 2 of those. So it's going to be y to the 6th, because you have 2 sets of 3. So there's our first one simplified. Now we have 4 to the 4th power. And 4 to the 4th power looks something like this. And what I like to do is break it down into groups. So I have 16 and 16. So now I just need to multiply 16 times 16. And I'm going to get 256. So I know I have 256. And now I have 4 sets of 2 y's. So that's going to be y to the 8th. But I'm not done because now I need to multiply this value and this value. So I do 9 times 256, which is going to be, let's see, 45, 50, 18, 19, 20, 21, 22, 23. So 2,350 304. I have 6 y's here and I have 8 y's here, so that's going to give me y to the 14th. So that would be my simplified value. So let's go over the rules. So our rules that we've learned so far. When adding or subtracting exponents, you keep your exponent sign, or your exponent value, the same. And you must have like terms. So that's our first rule. Our second rule is if you're multiplying with exponents, you just add your exponents. If you have exponent parentheses with exponents, and you have an exponent inside, you multiply your exponents. So those are some things we learned today. Be ready to work on this right after you read your lesson. Thanks. Bye.